Hello guys and welcome to a very interesting topic. I am Gletsmar B. Kasama and today we're going to talk about demand forecasting. And actually in this presentation, I would like to answer three things or three questions. Number one question is, what is demand forecasting? And number two, why demand forecasting is very important? And lastly, what are the methods of forecasting and how to use those methods? Now, this presentation, I would like to make it clear, is only focused on quantitative methods of forecasting. The qualitative will be in another presentation. So without further ado, let's start. What is demand forecasting? So demand forecasting is just the prediction of what will be the sales volume in the future years based on historical or past data. Like for example, to make it clear, let's have an example. As if we have a company which started at 2021 and we have a historical data of sales here already at 2021 of 100,000 units. But for simplicity, I decided to drop the three zeros. So again, we have sold 100 at 2021. And also, continuing the operations at 2022, we sold 170. And at 2023, as if today is 12/31/2023, we sold 258. As if, okay? Now, we have to estimate our sales for the next year. And that next year have not yet happened. That's forecasting. And our forecast will be based on this past sales data. Okay? So again, that's forecasting. Now, let's go to the second question. And that is, why is demand forecasting very important? So let's have a short answer. So, the company should make demand forecasting so that the company can prepare for the upcoming year or years. Now, if you have an idea on how much will be sold in the next year, you can answer the following questions. Number one, how much inventory or ingredients or raw materials if you manufacture goods are you going to buy or make in the coming years? And number two, how many labor hours are needed in the coming years? Or do the company need to hire more workers or not? And number three, do we need additional machinery or not? So that's how important forecasting is. And once again, demand forecasting is necessary for the company to prepare. Let's go to number three topic, which is the longest part in this presentation. So topic number three focuses on the question, what are the methods of forecasting and how to use those methods? Now, I told you that we're going to talk about quantitative methods only. And actually, in total, I'm going to present four quantitative methods. But before I do that, here's the sample problem that I presented a while ago. So again, we have sales for year 1 to year 3 already here. And our goal is to forecast what will be the amount for year 4. Now, let's go to the first method, which is the naive method, where you just have to copy the sales in the past year. Like in this example, if you are looking for the future demand in year 4, then we just have to copy the demand or sales in year 3. So this 258 here, it will now become the forecast on year 4. So that's naive method. It's as easy as that. The second method is also easy, but I have to confess that the arrangement of the methods in this presentation is from the easiest to the hardest. Now, moving forward, the second method of forecasting is the average method, where the forecasted sales in year 4 is just the average of the sales data in this past 3 years. So, we have this 100 plus 170 plus 258 from here divided by 3. And we're going to get 176 as the forecasted sales in year 4. Now, actually guys, the average method can also be modified. Like, you can consider only the amounts in the past 2 years only. Like, if we are to solve year 4 sales, we have the option to consider only the data in year 3 and year 2. We are going to ignore already the data in year 1 because it's the least recent one. Like, we consider only this 258 and this 170 and ignore this 100. So what you do next is you add these two and divide it by 2 and you will get 214 as the forecasted demand for year 4 under the 2-year moving average technique. But wait, there's more. Guys, you can still actually modify the average method into weighted average method where you assign weights to the historical data, and normally the more recent the data is, the more weight is assigned to it because it's more logical. Like for example, on this 3 sales data, let's put 5 as the weight for 2023 and then let's put 3 as the weight for 2022 sales data and 2 as the weight for 2021. Let's assume those, okay? Now, what will happen is 258 will be multiplied by its weight, which is 5, okay? Plus 170 times its weight, which is 3. And finally, we have 100 times 2. And then, we need to divide them by the sum of all the weights, which is 10, okay? Now, if we simplify this, it will look like this. And if we add this all up and then divide it by 10, we will get 200 as the sales forecast in year 4. Now, sometimes the weights are in the form of percentages. Like instead of this 532 as weights, they can be expressed as 50%, 30%, and 20%. So, if that's the case, the 258 will be multiplied with 0.50, which is the decimal form of 50%, and the 170 will be times 0.30, and the 100 sales at year 1 will be multiplied with 0.20. Now, simplify, and you are still going to get 200. So, there is no need to divide it by the sum of the weights because the 0.50 plus 0.30 plus 0.20 is still 1. So the answer will still be 200 even if we divide these with 1. So that's it. That's for the average method. Let's have the third method, which is the exponential smoothing. So let's have the same problem still, and let's have the same goal, which is to forecast the sales for year 4 or year 2024. So how do we do it? First of all, you need to know that exponential smoothing method uses a smoothing constant. So if the weighted average method has weights, exponential smoothing has a smoothing constant. Okay? Now, let's assume that the smoothing constant is 0.20. But what is really a smoothing constant? What is this 0.20 here? Think of this as the weight given to the past year's actual data because you will need the past year's data in predicting the sales. Like, if we want to get the year 4 forecasted sales, we need the actual data from year 3, which is this 258. And we need to assign a weight to it, which is again the smoothing constant. Now, actually guys, the full formula to get the year 4 forecasted sales is past year's actual data times the smoothing constant plus the past year's forecast times 1 minus smoothing constant. And I know that the second term is unfamiliar, but let me explain first this 1 minus smoothing constant. Okay? So you need to think of this as 100% minus the smoothing constant, which in our example is 0.20 or 20%. And if we do that, we will get 0.80 in this 1 minus smoothing constant. Meaning, these two, the smoothing constant, and this 1 minus smoothing constant should always be equal to 1 or 100%. So, if the smoothing constant here is 0.30 for example, this one here will become 0.70. And if the smoothing constant is 0.40 here, then this 1 minus smoothing constant will be 0.60. Okay? I hope you can still relate. Actually, guys, the challenging one to explain here is the forecast amount for year 3 because we need to solve for it. So this 258 here, it's not the forecast, it's the actual data of year 3. Again, we still need to solve the forecast for year 3 because we're going to use that in predicting the year 4 sales. How do we get the forecast for year 3? Actually, first, let's have the actual data. And again, these are those. Now, let's insert the second column here, and we're going to label it as the forecast. Now, you cannot get the forecast for year 3 if you're not going to start with year 1. So, let's start with the actual sales for year 1, which is 100. And actually, guys, you just have to copy it as the forecast in year 1. Now, let's continue in year 2. This is where the exponential smoothing method is used. This formula right here. Okay? So, actual data for previous year, which is 100, times the smoothing constant of 0.20, that's the one that we assumed, plus the forecast of the previous year, which is again, in year 1, we have 100 times 0.80. Again, that 0.80 is 1 minus the smoothing constant. And you will still get 100. Because 0.20 of this 100 is 20 and 0.80 of this 100 is 80. So 20 plus 80, it's still 100. Now, let's continue the pattern to year 3. So, actual data from year 2, which is 170, times the smoothing constant of 0.20 plus 0.80 times 100, which is the forecast of year 2. So, this here is 34 plus this here, which is 80, and we will get 114. And finally, since we have the forecast already for year 3, we can already forecast for year 4. So we just have to follow the same pattern. So we have 258 times the smoothing constant of 0.20, and that's 51.6. Plus this 114 forecast in year 3 times 1 minus smoothing constant again of 0.80, and that is equals 91.20. So 51.6 plus 91.20, and we have 142.80 or 143, which is now the forecasted sales in year 4 using the exponential smoothing and using the smoothing constant of 0.20. Welcome to the last method, which is also the most difficult method of the 4 that I'm going to introduce in this presentation. So, the last method that we're going to talk about is the least squares method or the regression analysis. So, we are still to use the same problem and we are still going to forecast the year 4 sales, but now we are going to use the least squares method or the regression analysis. Now, if this is the formula in order to forecast sales using exponential smoothing, under the least squares method or regression, we can get the forecast for year 4 by A plus BX. So, we just need to find the values for the A and B. And after that, you can already get the forecasted sales. Now, to get the A and the B, we need to simplify these two formulas. So we have summation of y equals n times A plus b times summation of x. That's the first formula. And the other one is summation of xy equals a times summation of x plus b times summation of x squared. And I know these formulas are very difficult to memorize, which is why in my college years, I read them as a na x. So that's the first formula, a na x. And the second one is xcx bex bex. Again, that's xcx bex bex. So because of that, I still remember these two formulas until now. Now, aside from memorizing, we need to get the amounts for these elements in these formulas, except for the A and B. And how do we do that? Of course, by getting first the actual data. So we have again, for year 1, we have 100. Year 2, we have 170. And year 3, we have 258. Now, in this first column, which talks about the years, year 1, year 2, and year 3, we need to label this column as X. And if we try to sum them all up, like 1 plus 2 plus 3, we will already get the summation of X, which is needed in these two formulas, specifically these two. Okay? Easy, right? Now, the sales data is to be labeled Y. And if you sum it up, you will already have the summation of Y, which is this one already. Again, easy, right? Now, let's add the third column. And let's name it X squared, because we need the summation of X squared here in this formula. Okay? Now, this X column amounts here will just be multiplied by its own. So here we have 1 times 1 equals 1, 2 times 2 equals 4, and 3 times 3 equals 9. Now, 1 plus 4 plus 9 equals 14, which is already the summation of X squared, which is necessary in this formula. Again, easy, right? Now, let's make a fourth column, and let's name it column XY. Because again, we need the summation of XY for this formula here. Now, you just have to multiply the numbers in this X, and then times the Y. It's as easy as that, okay? Now, 1 times 100, we have 100, and 2 times 170, we have 340, and 3 times 258, we have 774. Next is we have to sum them all up, and we will have 1,214, which is already the summation of XY. And we're going to use that in this. Easy, right? Now, we are ready for the next step. The next step is to use these results in these two formulas. So, summation of y, we have 528, and then we have n times a, or na, right? So, actually guys, the n is the number of years or number of items considered, or the number of items that we used. And in this situation, we use the data for 3 years. So, our n is actually 3. So, we have 3 times a, or 3a. And then, we have plus summation of x times b. So, summation of x is 6 based on this, right? So, we need to write 6b, or 6 times b. I know, this should be b6, but b times 6, or 6 times b, that's just the same. Plus, 6b is more appropriate for equations. So, we need to put 6b. Okay? So, that's the first equation. Now, let's substitute on the second equation. So, we have summation of xy, which is 1,214, equals a times summation of x. And again, summation of x is 6. So, we have 6a. Plus, we have b times summation of x squared, or the bex, and the summation of x squared based on this is 14. So we put here 14b. Okay? So that's how you substitute this to the equations. Again, easy, right? The next step is to extract the a and b values. So to extract one of them, you need to eliminate one of them first. So that is done in order to have only one unknown, because you cannot solve both of them at the same time. So, for me, I chose to eliminate a, because this 3a here, if you multiply it with negative 2, this will become negative 6a, which will become the total opposite of this positive 6a here. And if you simplify, then these two can be eliminated, leaving 6b and 14b alone. In short, I chose to eliminate a because it's easier. But you can also choose to eliminate b. It's up to you. We will still arrive at the same amounts for a and b, even if you choose to eliminate the b. Okay? Now, moving forward. The problem is, if we multiply this 3a by negative 2, the whole equation will be affected. Like, we need to multiply also this 528 and this 6b here by negative 2. So, let's do just that. Okay? Now, if we do that, then this equation will be changed. Therefore, we can cross them out. And we can make a new equation. So, negative 2 times 528, we have negative 1056. And then, equals 3a times negative 2. And we have negative 6a. And then, we have 6b times negative 2. And we will have negative 12p. Okay? Now, we need to simplify these two equations. So, positive 1,214 and this negative 1,056 equals 158. And then, we have positive 6a and this negative 6a. So, we're going to cancel them. And lastly, we have positive 14b versus negative 12b. And we have positive 2b as simplified. Okay? Now, to get the b alone, we divide the equation by 2 and b will equal to 79, which is again 158 divided by 2. Now, we need to get the a because we already have the b. So this one's going to be easier because you just have to select any of these three equations, including this crushed out equation. And then, you substitute the b, which is 79, to the b in these three equations. I will emphasize again, you can choose any one of these three equations, and you will still get the same amount for a and b. So, for me, I'll choose this crushed out equation. Okay? So again, that's 528 equals 3a plus 6b. Now, if we substitute this 79, we will have this. And actually, 6 times 79 is equal to 474. Now, let's combine like terms by means of deducting this 474 from both sides of the equation. And we have to cancel this. And we have 528 minus 474 equals 54. And in this side of the equation, we have 3a only. So, to simplify further, and in order to get the a, we need to divide the equation by 3. So, in effect, a is equals 18. And again, that's from 54 divided by 3. So now, we have the values for a and b. Since we already have the values for a and b, then we can already forecast for the year 4 sales. And again, we have to use this a plus bx. So substituting, we have a as 18 plus b as 79 and times x. So this x is actually what year would you want to forecast. And in this situation, since we want to forecast year 4, so the x will be 4. So that's the complete substitution. Now, let's simplify. We have 18 plus 79 times 4. 79 times 4 is actually 316. So it will become 18 plus 316 and it will be equal to 334. And that's already the forecast for year 4 sales using the least squares method or regression analysis. Now, the beauty of having this formula already is that you can already make a forecast for year 5 or year 10 by just changing the x. Like if you want to forecast the year 5, you can just change this 4 to 5. And that's it. So that would be all for least squares method and regression analysis. Now, let's have the final slide for this presentation. Welcome to the last slide. So, again, if you remembered, we have a common problem, this one, and we tried to forecast the year 4 sales using different methods. And over the course of the presentation, we got these different answers under different methods. Now, to master forecasting, here are 3 different things that I would like to emphasize. Number 1, do not include outliers in your computations. So what are those outliers? For example, you are forecasting for year 5. And for example, the actual sales for year 4 is 0 because, for example, of pandemic, for example. So, don't use the data for year 4 because it does not follow the regular pattern of the sales data. So, in here, the regular pattern is that from year 1 to year 3, it is increasing, right? So, if in year 4, the sales is 0, then it is an outlier. So, if it is an outlier, never include them in your forecasting in order to get reliable results. Because if you are going to include them, then your forecasting results will be unreliable. Okay? So that's it for number 1. Number 2 is that in answering which of the methods should you use, there are computations that you can do. If you wanted to know which of the methods featured in this presentation is more appropriate in your company. And that would be presented next. And lastly, there are also qualitative methods of forecasting, which is appropriate for companies with new products to be launched. Because if the product is new, then there will be no historical or past data. So, if there is no historical data or past data, you cannot use these quantitative methods. And that would also be presented next. So, that's the end of my topic. So, thank you so much for listening. I'm Gladsmar B. Kasama. And once again, thank you.